So in order to start understanding this process that the moon went through to have this happen to it, we need to look very carefully at orbits once again. And if you recall from an earlier video, we said that orbits are a delicate balance between the force of gravity, which are labeled F sub g, and v, the speed of the planet. So again, this is the force of gravity that an orbiting planet is being pulled on. This is how fast the planet's moving in its orbit. And we can see that the moon has a particular speed to take it around the sun, to take it around the Earth once every 30 days, and that sort of thing. Like this number here comes directly from sort of the speed of the moon. So that's the way orbits work. So we have to look a little more closely at them, and let me just do it this way. Suppose that the sun was here, okay, as always. There's the sun. And suppose that the Earth was here, okay? And as we know, the reason why the Earth doesn't fly off into outer space is because the force of the sun is sort of pulling it in this way. There's an F sub g, a force of gravity, because of the sun here. The sun is always pulling Earth this way, and that sort of always keeps the Earth in its orbit here. So I really want you to encourage you to look back maybe at least at the video on the orbital simulation if you've forgotten some of this. But there's something very peculiar about the orbit now if we zoom in like this. So it turns out that the orbit idea of the orbit is really only based around the exact center of the planet. So if the Earth is sort of following its orbit like this, you know, here it goes. Here's sort of its orbital line. The orbital path actually just goes right through the center of the planet. That's kind of an important point here. And that's what Isaac Newton sort of proposed here, is that the force of gravity really only acts through the center of a planet. But unfortunately, or fortunately, however you want to think about it, planets are a little bit bigger than just one little dot that would possibly pass through its orbit like that. They're just, you know, they're huge like that. And so what happens then is the delicate balance here for an orbit that I just discussed, this delicate balance really only applies to this center point right here. Really only applies, say, to this point right here. The delicate balance really only applies to that center point right there. That's the only point that's actually in a really delicate balance. You're scratching your head going, this is kind of peculiar then. I wonder how any of this works. If the delicate balance is here, why is it that this is allowed to orbit and this is allowed to orbit? Because it doesn't seem like those are on the position of being in a delicate balance. And yeah, it's actually quite interesting how these sections are able to exist. So it turns out that you have to think of a couple of things here. How is it they're able to exist? Well, two things. These parts of the planet here, at least for the inner planets, these are all made out of rock, okay? And rock is very strong. And so if you could imagine, for instance, here, maybe get some brownish color going here for some rock. Like you might imagine rocks like this are all sort of together like this. And indeed the rocks, they sort of have some, I don't really know what to call it exactly here. Maybe some strength between them, between these cracks here, that might just be due to friction. I guess it isn't a great idea to write black on gray, but something like that. You can think of it like friction or something that sort of makes them just stick together. But the stickiness there, of course, also has something to do with the energy of the rocks. And I'll just sort of leave it like that. The energy that the rocks might have, like it might be really hard to pull this rock out because of friction it has with the other ones. And that's what I mean. It might take some energy to do that. But all told, I'm not trying to put forth any really cool scientific theory here or anything like that. I'm just saying here by that's inside the circle here, that basically all I'm saying here is that rocks are strong. Okay, and so certainly if one part of a rock right here is not on the delicate balance point, well, the rocks are strong enough to hold it. Okay, so that's part one. So you see how sort of difficult this is already getting. The rocks are not on the delicate balance point, but they're able to sort of exist because rocks are strong and it doesn't break apart, but they do sometimes also break, which we'll get into very late in the class. So I'll pick this idea up in the next video.